Okay, Module 1, Section 8, Objective 9, and this is in the application section instead of dividing. And we want to understand and calculate the area of a rectangular figure. Okay, in your packet you have a page that looks like this, and it says use square tiles to find the area of each figure. Record your answers, be prepared to explain, and use 1-inch colored square tiles. You probably don't have any. Okay, so I broke it up for you into squares. Okay, so let's take a look at these. If I want to find the area, what I'm finding is the gray part. Okay, how big is the gray portion inside the shape? Okay, remember perimeter is the rim or the outside of the shape, but the area is everything on the outside. Okay, or sorry, on the inside. So basically, I want to know how big that is with a number attached. Okay. So to do that, we're counting 1-inch square tiles. Okay, I'm going to change colors just so that you can see what I'm talking about. Weird color, but that's all right. Here we go. Okay, so that one square, if it's a 1-inch square tile, this is 1 square inch. And what that means is it's 1 inch on this side, and it's 1 inch on this side, and on this side, and on this side. So every side is 1 inch. So that's a 1-inch square. Okay, so how many of those 1-inch squares do I have? Okay, you could count them individually and, just do it that way. So we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So we have 24 squares. So we have 24 1-inch squares. So that would be 24 square inches for that area. Okay, you can do the same thing for all the others, but there could be other ways of figuring out the area that aren't counting things up. I don't want to count 24 every single time, right? So the blue one, we know we have 6 across and we have 4 down. So we have 4 rows of 6 squares each. So we have 6, 6, 6, 6. That's repeated addition. In other words, multiply. So 4 times 6, there are 24 squares here, and each square is 1 inch squared. So 24 inches squared, 24 inches squared. These two have the same area. So in other words, if you were going to, cover it with stamps that are 1 inch squared, you take the same number of stamps. Okay? If these were square feet instead of square inches, it would take the same number of square tiles to cover whatever shape that floor was. Okay, let's take a look at the last one here. Probably shouldn't have used green because now it's going to blend, but it's a different shade of green. We'll be good. I'm going to break this into 2 sections that I know. Okay, so this top section has 2 rows, and each row has 1, 2, 3, 4, 5, 6, 7, 8. So 2 times 8 is 16. Now this bottom part also has 2 rows, but there are 4 in each row. So then I'm going to add 16 and 8, and I also get 24 squares. So all 3 of those shapes have the same area. Because if I were to cut pieces out and shove them in different places, you would get the same thing. Okay, for example, if I cut this part off right here, that 4x4, and tacked it in over here, the result would be 4 by 6, which is exactly what I have here. Okay, On this one, if I cut this piece off and moved it up here, I would also have a 4 by 6. Okay? The idea is that the shapes are the same area because they have the same number of squares that are the same size. Okay, make a rectangle with the square tiles. So these are those tiles that you don't have that have an area of 8 square units, 5 square units, and 12 square units. So let's start with the 8. What do you notice about the dimensions of the rectangles? How do you find the area of a rectangle without using square tiles? Okay, so let's start with 8. So we could just have a long row, 3, 4, 5, 6, 7, 8. And I got carried away, right? Okay, so if I have one row that's 8 squares long, that's a rectangle, isn't it? And what's the area of that? How many squares did it take? So it's 8 square inches because each one of those squares is 1 inch by 1 inch. It's a 1 inch square. Okay, so what if I did 2 rows of 4 squares each, right? 2 rows, 4 squares. So 1, 2, 3, 4, 5, 6, 7, 8 square inches. Okay. Another configuration you could do would be 4 by 2, but can you see how this is exactly the same as that one? It's just twisted. Okay, so we're not going to worry about that. So if I were to cut these off and move them up here, I would still get the first image, right? Okay, so what do we notice about the dimensions? 1 by 8 multiplies to give you 8. 2 and 4 multiply to give you 4. Does it work with the 12? Let's find out. Okay, so 12. We have 1 by 12, and I'm not going to draw each individual one. 1 by 12. If I had 2 rows, and I have 1, 2, 3, 4, 5, 6, right? Because there's my 12 squares. So this would be 2 by 6 to give me 12 squares total, but now it's in rectangular form. Okay, so 3 rows. How many would I need? I need 4, wouldn't I? 3, 6, 9, 12. So 3 times 4 is 12. And I could go on, but that would be 4 by 3, which is the same as this one, twisted. And then 6 by 2 is this one, and 12 by 1 is that one. So how do I find the area of any rectangle without using square tiles? You use the formula. And the formula for the area of a rectangle is length times width. Length is usually the long one, and width is usually the small one, but it doesn't matter because multiply is commutative, so it doesn't matter which one comes first. You just multiply both. If you want to be specific with a square, since the sides are the same, you can use side times side. And since exponents are repeated multiply, we could write it as an exponent instead. So area is equal to side squared. Okay, or it is also a rectangle, so you could just say length times width. So there's the length, there's the width. It's the same thing. So imagine a fenced-in grass park. The fence is the perimeter, so here's your perimeter, and the grass is the area. Okay, so inside the shape is the area, and just the outside of the shape is the perimeter. Okay? Remember rim, it's the outside, the rim of the shape. Okay, so area is all of the inside, and area is going to be in whatever it is squared. So since this is a park, let's say it's yards. Okay, so this is maybe 20 yards across and 15 yards this way. Okay, so perimeter is going to be, just writing it completely out, 20 plus 15 plus 20 plus 15, because we want to go 20, 15, another 20, and another 15. So this gives you 40. This gives you 30. Add those together, so it's 70 yards all the way around, because it's just the distance around the outside. Now, the area is different because you're counting square yards this time. Okay? So, area is length times width. So the length is 20 and the width is 15. You multiply those, I'll just give it to you, is 300. And what are we counting? Square yards. Okay, so area, the label is always squared, and perimeter, it is never squared, it's just plain. Okay, so here we go, finding the area of each figure. So I always start with the formula. This formula is pretty easy, so you don't have to worry about it, but you'll eventually get some more complicated ones, so it's really nice to write it down first. And now we figure out which variable represents which number. Okay, so length, I'm going to say, is the long side, so 15. And width is going to be the short side, which is 7. And shoving them right next to each other means multiply. So 15 times 7, we get 35, carry the 3. 7 times 1 is 7, add 3 is 10. So it's 105 meters squared. And that's your answer. Okay, let's do the next one. So, starting with our formula, we have area equals length times width. You can put a dot, you can put an X. I don't like using an X, I've told you, because X looks like a variable. And now since we're talking about letters already, we don't want to throw in something that's going to throw us off. Okay, so I'm going to say length is the long one, so that's going to be the 12. So, and then times by the width, which is 3. So 3 times 12 is 36. And since it's area, we're going to do yards squared. And that's your answer. Totally easy. Now these two don't have pictures, but you could draw it if it would help you. I'm not going to worry about it because we already have the information right here. Okay, so let's say I had length is 12, right? So we have a 12 there, and width is 4, so width is 4. We're timesing those, so we get 4 times 12 is 48. And since it's in feet, it's going to be feet squared. Okay, last one here. Area is equal to length times width. So we have the length is 30. So length is 30. So 30 times, and width is 50. So we put a 50 where the W was. And now 30 times 50, we'll use our little shortcut. So 3 times 5 is 15. 0 times 0. means you have 2 zeros at the end. So inches squared. And there you go.